Our next speaker, Joyann Boyce, she is not only an advocate for diversity and inclusions for marketing and technology, she's also a social media consultant and founder of The Social Detail, which is organizations that work with a range of different communities, including the Bristol City Council, the Adobe XD, Set Squared, and Future Space. She's currently a data fellow with the Southwest Creative Technology Network, and she has been researching about how bias within data could be positively used and benefit for marginalized groups. So she's going to share with us how open source data can make bias a positive impact for marginalized groups, and I'm really excited about that. So let's welcome Joyann.
Thank you so much for that introduction. Yeah, so as mentioned, I am exploring as part of a research project if bias could be used as a solution for bias in itself. So a little bit about me. My name's Joyann Boyce. My pronouns are she and her, and I'm the founder of The Social Detail. The Social Detail is a social media marketing agency helping brands and communities to be more inclusive with their content. We believe in inclusive marketing, and essentially that just means that within your target audience, that target audience is diverse, and you can create content to attract and to represent them as well. As part of my research and as part of my work in inclusive marketing, I stumbled upon data bias, and then I became a data fellow with the Southwest Creative Network. So all this research I'm about to share with you has been supported by the Southwest Creative Network based here in the UK, and it's really helped me accelerate my research and understanding from machine learning to AI to a whole bunch of things that are very new to me. So where did it start? They can shape the perception of a group, of a person, of a whole genre. And that was very apparent to me when I began teaching inclusive marketing, and how data is used to either confirm biases or set loops of confirmation bias. In a study done by the Pudding in 2019, they looked at the past 19 years, of the covers of Vogue, and then they charted this using machine learning in terms of the complexion of the covers and the models on the covers. What they found is that there was a bias to lighter skin tones. Essentially, there was colorism within the covers of the magazines. And then they used this data to really understand, what was it? Was it that there wasn't just any representation on models or people of darker skin tone to represent on the magazine cover? There were. However, the marketers and the agencies were using the data that once they put out covers which featured lighter skin tones, they would produce more buy and then produce more income for the magazines. But there was never any true tests in terms of darker skin tones. What was also interesting in the study was that the majority of the darker skin tones, the last 4 on that timeline you can see, were of the same person. So that's what led into my research question. We've seen through society how bias in data sets and machine learning and AI can negatively impact those of marginalized groups. And when I speak of marginalized groups, I speak of, in Western society, there tend to normally be women, disabled people, people of darker skin tones, Black people, and anyone who's an intersection of those varieties. So my questions were looking at, how can we use bias data to promote inclusion? We already know what happens when those marginalized groups are not included in the data sets, but if we could manipulate that data set so that they are supported and represented or overrepresented, what would that include? So that's when I started to look into machine learning and how the process and the journey of data, and where could I influence and essentially bias data to benefit marginalized groups. And to understand where I could bias the data in the machine learning model, I had to actually figure out what the data pipeline was. What happens with data before we even get to AI that can't recognize darker skin tones, or what happens to the data before we get to driverless cars that can't see people. So many varieties we're seeing in society right now, but what happens to the data before that point? So looking at the data pipeline, there seems to be very clear areas where we can influence and bias the data. In the data collection, this tends to look at how and where and what type of data is collected. The majority of the time, there's someone deciding what data is valuable to collect and someone putting in their own bias into what percentages of, in terms of people, to collect that data from. Once that data is collected, it is then labeled. Data can be labeled either by human labelers, which majority of machine learning is actually human labelers, and or by machines that have already learned how to label patterns, but they would have still learned those labeling systems from human labelers originally. That's another aspect in which bias can be introduced. With anecdotal studies and me being new to the area, I've spoken to data scientists and computer visioning, and a tendency that tends to happen is when a human labeler is labeling an image of someone of the same race of them, they're able to guess that person's age correctly within a 5-year span. However, if that person's not of the same race with them, there's a 10-year span. And also when you're labeling images of faces, if the labelers are of a certain ethnicity, that ethnicity within the data set has a higher percentage of being correct when the model is trained later on. So there's already areas of where marginalized individuals can be inputted in the labeling and benefit from this, as we can see with the race labeling. However, what tends to happen after the labeling action is data cleaning. And the person or the data scientist or the machine learning engineer can remove that weighted bias in the favor of marginalized people and clean out what they consider not necessarily beneficial to their end goal. So that's another aspect in which the data can be manipulated. Then we have the model training and the model testing. This is the more kind of known area of machine learning and AI where they're actually building a model to do a thing. However, that model is trained on a certain set of data and then tested with a certain set of data. If that testing data is not representative of marginalized groups and communities, the model can reinforce the biases within. That's another area. If we were to, say, for an example, create a data set that was opposite to a population of a country, if the population of the country was 80% men and 20% women, we would want to create a data set that would be 80% women and 20% men. As going through all these stages, that percentage of women will get reduced and cleaned out, for lack of a better phrase. So that led me to start thinking about intersectionality and borrowing heavily from intersectional feminism, which very much leans on we will all rise once the most marginalized of us in the community are considered equal. So how does that look in data? What does intersectional data look like? And can it even be created? So here in the UK, when we speak about marginalized communities, a lot of those characteristics and aspects are protected characteristics, which means by law, you're not allowed to discriminate against those characteristics, be it someone's age, disability, gender, race or skin tone, belief, sexual orientation. So trying to create intersectional data sets, we'll be leaning on labeling some of those characteristics, which can make these individuals even more so vulnerable. And are all of these characteristics able to be binary is another aspect of the questions I've been exploring. As things and words and language change with time, any kind of model that would be beneficial for marginalized groups needs to be up to date with the changes of the language and the labels that are used for various people from marginalized backgrounds. So this intersectional data set, very much thinking in the machine learning, also lends itself to what I do a lot in marketing. In marketing, when putting together a campaign or putting together any kind of initiative or outreach, we think of target personas. And target personas are very much labels in a sense where we think about demographic labels. So is it a woman, their age, and all these aspects in what would make them interested in the product or the campaign that we're creating. Then we also think about their interests. Are they interested in magazines, in various softwares, or any kind of things that we can introduce into the campaign? So there's already ways to make binary to make marginalized data binary, as we do in marketing, and behavioral traits, and learn from that data, but looking at how this can even be applied to machine learning. It led me to think if it was possible to get data scientists and machine learning engineers to think a little bit more like marketers, to think a little bit more about the complexity of individuals and people when they're setting up data labels. So this I created while on the fellowship. I began to learn a little bit of code, very basic, but with the support of a coding mentor, I created a persona shuffle, which is going to be used as a training tool, ideally, for anyone dealing with data to think about their data a little bit more intersectionally. If you want to try this tool, there's the link bit.ly/persona shuffle. The user, once they're on this tool, this training website, is asked a series of questions, whether they think that the person is likely to be their character or their target audience or not, and then ask the following series of questions. Whether you answer yes or no to these questions is quite arbitrary. It's more so how long you take to respond. So the images that are shown are used from the This Person Does Not Exist website. So they're all machine learning models, images, so these people are not real. And then the questions that the individuals are asked are thinking of their target audience in intersectionality. So seek faith, a male, may have a loss of hearing, maybe heterosexual, maybe of a certain age, and maybe have a certain skin tone. These are all characteristics that apply to people in layers as you target them, but it's not necessarily something that a machine learning expert would consider when building a model. So that was looking at the data pipeline in terms of how could I manipulate the data in collection, labeling, and cleaning. I then went on to explore the model testing and training aspect. So what would a model be like if it was trained on intersectional data sets? And what kind of biases would that model create? Because once you're putting in weighted data and biased data, your machine's going to also learn those things. So I started exploring platforms like Microsoft Azure, Google AutoML for cloud machine learning, and IBM, I want to say Watson, but there are tons of platforms out there, open source and cloud hosted, that you can build and test your own models with these data sets. So for one model I built, I chose pictures of Michelle Obama and Lupita Nyong'o. And in this model, it simply just identifies whether the picture is Michelle or whether it's Lupita. And it only has one label set, which is the names of Lupita or Michelle. So that was the outlook of what you can do with weighted or intersectional data. All of this applies to open source data in the sense of a lot of machine learning, processing, training uses open source data. And that data is collected at a certain time, and it goes through that data pipeline, and each aspect of the data pipeline, it's manipulated and biased in some way. So when working with open source data sets or looking to train a machine model with open source, is to keep all those things in mind and possibly think of what intersections can I look at how this data was collected, who would have been removed when the data was cleaned, or who would have labeled the data when it was uploaded, the time. There's a lot of questions in using open source data. And one of the main biases with open source data is it tends to be contributed to by those already aware. And given current society, that tends to be mostly white men. So there's a lack of representation in those data sets. So whenever working with open source data sets, it's good to ask, where is the bias? Because there will always be bias. In my research thus far, I have found quite a few challenges. Being new to the sector has been one. I don't know machine learning. This was all new to me, but I very much wanted to understand how could this be used to benefit those. So I took a lot of time to understand, to learn, to speak to people in the sector who are experts in their area. Another challenge with the research is that there's a lot of mistrust. Science, research, IT, tech has been tested or has collected information from marginalized communities. There's a lot of research around how facial recognition software use the data from prison systems and photos to build the very first models. And this leads to a mistrust from marginalized groups of anyone trying to collect their data, which is very valid. But this is also a difficulty, as in if women, Black people, disabled people are not included in the data sets and they have a mistrust to be included, then they're completely forgotten in the end product. And due to this mistrust and this imbalance in the past, it also raises a lot of issue around ethics. Something which is used to benefit and support those of marginalized backgrounds could also be used to hurt them, unfortunately. We've seen this recently with the removal of facial recognition softwares off of the shelves as the Black Lives Matter campaign has been going on, quite active in America and around the world. Some people have used that facial recognition software to falsely identify protesters and arrest them or cause harm in some way. That was not the intention of it, but that's where it was used. So in going down this research, I've also been very aware that my intention may not be for this to be used to further oppress women, Black people, disabled people, but it could be a possibility. And that could be a possibility of the end use. And one of the biggest aspects of this as well is the cost. The cost of getting into machine learning data sets, storing data is great. You can use a lot of free softwares or machine learning models like Tenant, but you need to have access to very high processing computers. You need to have access to be able to store large quantities of data. So without that knowledge or without the access to that type of computing, the cost can build very quickly. There are, if you just want to get started and test things out, like I did with my Michelle Lupita model, I simply used the free credits you get from Google AutoML. So those were the challenges. And now what next? So I am about 3/4 of the way through my research, and I'm looking at how I can further build intersectional data sets, how I can build models which use these data sets to benefit people on what aspects they could be used, and also exploring what biases these models create in their own sense when the majority of the community, the majority of the current present in the community is removed. What else can we learn from these? I'm also exploring the ethics behind it all. And as of January 2021, I'm going to be starting a data science master's to further my understanding in the whole area. Takeaway. My main takeaway for anyone stepping into machine learning, using open source data, or using any kind of data in itself is to start with bias in mind. A lot of the community and a lot of things happening is speaking about fair data, which can sometimes imply that there's no bias involved, but bias is always present in the room. It's always present in the data set. And if you start for it in mind, you wouldn't be surprised like Facebook was, or like IBM was, or any of these big companies when that bias appears later down the line. So start with bias in mind, and you'll inevitably create and sustain something that is beneficial for a lot more people. So thank you very much. You can keep up with me on Twitter at Joyann Boyce, and I'll be publishing write-ups of my research and my findings on the Southwest Creative Network website. So thank you very much.